This is my second choice activity. We're going over the second unit, radioactivity. So firstly is vocab again. So we have fission, the process of splitting an atomic nucleus into two or more nuclei with smaller masses, releasing large amounts of energy. Fusion is reaction when two or more atomic nuclei form a nucleus with a larger mass, releasing large amounts of energy. But we can't do this yet. We're not that advanced yet. And half-life, amount of time it takes for half the nuclei in a sample of a radioactive isotope to decay. Isotope, an atom of an element that has a specific number of neutrons. Nuclear energy, the energy released during nuclear fission or fusion, especially when used to generate electricity. That's how a lot of people get electricity through nuclear power plants. Radioactive decay is the changes in an atom once it has become unstable and begins to lose its particles. Strong force is the attractive force that acts between protons and neutrons and an atomic nucleus. Radioactivity, process that occurs when a nucleus decays and emits matter and energy. Radioactive isotope, elements such as radium whose nucleus breaks down and emits particles and energy. And radiation, the transfer of energy by electromagnetic waves. So now we're gonna be doing going over nuclear power plants. So in a nuclear power plant, there are, of course, you've got uranium-235 and they chain reactors. And so in those reactors, they've got all sorts of parts. And so they've got pipes going from underground with the water, pumping it into the around the U-235 thing, around U-235 area, where they're gonna shoot a neutron in there, so it gets unstable and splits fission, and creates large amounts of, and it gets so hot, so it burns, it like boils all the water into steam, and that then goes through something into a wind turbine, which turns that to basically makes us energy. And it gives us a lot. Like the most in the world. And uranium-235 is very sustainable because it doesn't leave any pollution. It's cheap after you've built the power plant. Building the power plant itself is expensive. Its downsides are some nuclear exposure to radiation, really bad for you. Radiation can also cure some cancers, because if you use it in the right way, it can be very helpful, like creating tons of energy, for example. So yeah. Hat charts. Let's go over hat charts. So a hat chart is a really easy way of finding out something. So you're gonna want to go 3 columns, just like this, with a square box around it. And so you're gonna have 1, 2, 3 right there. You're gonna be writing H in the first one, A in the second one, and T in the last one. So in the first one that says H, you're gonna label it 0 through 5. And then one that says A, that's for your grams. So you're gonna write, this is the easy way to find out a half-life. So you're gonna write your grams. So if it starts at 200, you're gonna write 200, and for time, you're gonna put 0 for the first one. So let's do 200, for example. So after 1 half-life, so under H, let's say 1. Under A, it should be 100 grams, and under T, it would be the half-life. And then number 2, so you're gonna you're just gonna add another half-life, or times 2, that first one you did. And then the grams will be 50. After 3, you'll just times 3 that first one, and the grams will be 25. So for the half-life, you're just gonna multiply it by the first half-life, or you can just add it every time. and for grams, you're going to divide by 2 every single time. It's a good way of finding out the mass or the half-life or all that stuff. Okay, now nuclear fission reactions. So these are like long math problems, kind of. So I've got one. It's U-235-92, because that's what it is, atomic number 92, plus 1 neutron, which is going to make it U-236-92. And then that's going to be arrow question mark 93/36 Kr krypton plus 3 neutrons. So that's going to be 96 krypton and 236 uranium, and so it's going to be 236 equals X plus 96. Then you're again gonna minus 96 out of 236 and get 140. So you're gonna keep that number. That's your top number. You're gonna draw a box and you're gonna put that in the top left corner. And then you have 92 in the bottom. So what do you do with that? You're gonna take that and you're gonna there's gonna be another one now. It's gonna be 92, 0 neutrons, so you don't add anything to it, equals X plus 36. So then you're going to do 92 minus 36. And that would be 56, I believe. And so that's in your bottom box. So it'll be 140 or 56. And so you're going to go to the periodic table. And you're going to find the atom in the 56th spot, which I'm pretty sure is barium, I think. I'm not sure. I think that's what it is, though. And last thing I'm going over. No, that's it for the video. Thank you.